A junction box is a device used to connect and splice multiple wires together. It provides a secure and insulated enclosure for electrical connections. A pull box is a device used to facilitate the pulling of wires through a conduit. It provides an access point to add or remove wires without having to open the conduit itself. Based on the description of the need to install boxes above the ceiling to introduce multiple conduit runs from various locations into a single home run conduit linked back to a panel, these boxes would be considered pull boxes, not junction boxes. The purpose of these boxes is to provide access for pulling wires into the conduit, not to splice wires. There is no specific national electrical code requirement that prohibits installing pull boxes above inaccessible ceilings. However, some manufacturers may recommend that pull boxes be accessible to facilitate wire pulling and maintenance. To address both the need for accessibility and the requirement for continuous wire runs, it is recommended to firstly plan conduit routes carefully, secondly design conduit runs to minimize the number of locations where pull boxes are needed, thirdly use accessible pull boxes where possible, installing pull boxes in areas that can be accessed after a ceiling installation such as at light fixtures or ceiling fans, fourthly document box locations, keeping a record of the location of all pull boxes for future reference, and fifthly consider using test access panels, installing small access panels that allow for access to pull boxes above the ceiling if deemed necessary. In the described situation, the boxes needed to install above the ceiling would typically be considered pull boxes, not junction boxes. However, it is advisable to follow best practices and consult with the manufacturer's recommendations for accessibility. The National Electrical Code, or NEC, covers the safe installation of electrical wiring and equipment. It's important to understand the definitions and requirements related to junction boxes and pull boxes to ensure compliance and safety. A junction box is primarily used for joining or branching electrical wires. Inside a junction box, you'll typically find wire connectors or splices that create a continuous electrical path. These boxes are designed to protect the connections from physical damage and provide a degree of electrical insulation. On the other hand, a pull box serves a different purpose. It's designed to make it easier to pull wires through long or complex conduit runs. Pull boxes provide access points along the conduit path, reducing the pulling force required and preventing damage to the wires. Pull boxes typically don't contain any wire splices or connections. When determining whether a box is a junction box or a pull box, consider its function. If the box is used to make electrical connections, it's a junction box. If it's used to facilitate wire pulling, it's a pull box. The National Electrical Code has specific requirements for both junction boxes and pull boxes. For junction boxes, the NEC specifies requirements for box size, fill capacity, and secure mounting. The size of the junction box must be sufficient to accommodate the number and size of conductors entering and exiting the box. The fill capacity, which refers to the maximum number of conductors allowed in a box, is determined by NEC tables based on the box size and conductor size. Junction boxes must be securely mounted to a structural surface. For pull boxes, the NEC specifies requirements for box size and accessibility. The size of the pull box must be sufficient to allow for the proper bending radius of the conductors being pulled. The box must be accessible to allow for wire pulling and maintenance. The NEC doesn't explicitly prohibit installing pull boxes above inaccessible ceilings. However, the code emphasizes the importance of accessibility for electrical equipment to allow for inspection, maintenance, and repairs. Therefore, it's generally recommended to install pull boxes in accessible locations whenever possible. If pull boxes must be installed above inaccessible ceilings, consider the following best practices. Firstly, carefully plan the conduit routes to minimize the number of pull boxes needed. Secondly, use the largest conduit size practical to reduce the pulling force required. Thirdly, consider using intermediate pull points such as conduits to break up long conduit runs. Fourthly, document the location of all pull boxes for future reference. Fifthly, use wire pulling lubricant to reduce friction. Also, consider the manufacturer's recommendations for pull box accessibility. Some manufacturers may provide specific guidelines for installing their products in inaccessible locations. When planning conduit routes, aim to minimize the number of bends and offsets. Each bend and offset increases the pulling force required and the risk of wire damage. Use the largest radius sweeps possible to reduce the pulling force. Avoid sharp bends or kinks in the conduit. When pulling wires through conduit, use a wire pulling lubricant to reduce friction. Apply the lubricant liberally to the wires as they enter the conduit. Use a wire pulling machine or hand-operated pulling device to ensure a smooth and controlled pull. Avoid pulling the wires too quickly, as this can damage the insulation. After pulling the wires, inspect them for any signs of damage. Check for cuts, abrasions, or kinks in the insulation. If any damage is found, replace the affected wires. When selecting pull boxes, consider the material and construction. Pull boxes are typically made of metal or non-metallic materials. Metal pull boxes are more durable and provide better protection against physical damage. Non-metallic pull boxes are lighter weight and resistant to corrosion. Choose a pull box that is suitable for the environment in which it will be installed. The size of the pull box must be sufficient to accommodate the number and size of conductors being pulled. Refer to NEC tables to determine the minimum pull box size based on the conduit size and the number of conductors. Install the pull box in a location that is easily accessible for wire pulling and maintenance. Avoid installing pull boxes in locations that are obstructed by other equipment or structures. Securely mount the pull box to a structural surface. Use appropriate fasteners to ensure that the box is properly supported. Label the pull box to indicate its purpose. Use a permanent marker or label maker to clearly identify the box as a pull box. Keep a record of the location of all pull boxes for future reference. This will make it easier to locate the boxes for inspection, maintenance, and repairs. When working with electrical wiring and equipment, always follow safe work practices. To energize the circuit before working on any electrical components. Wear appropriate personal protective equipment such as safety glasses and gloves. Use insulated tools to prevent electric shock. If you are not qualified to work on electrical systems, hire a qualified electrician. Understanding the difference between junction boxes and pull boxes is essential for safe and compliant electrical installations. By following the NEC requirements and best practices, you can ensure that your electrical systems are properly installed and maintained. Always consult the latest edition of the National Electrical Code and local electrical codes for specific requirements in your area. It is important to note that electrical codes and regulations can vary depending on the jurisdiction. Always check with your local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and regulations. Additional considerations for pull box installations include ensuring proper grounding and bonding. Grounding provides a path for fault current to flow back to the source, helping to protect against electric shock. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Follow NEC requirements for grounding and bonding to ensure the safety of the electrical system. Also, consider the environmental conditions when selecting and installing pull boxes. In wet or damp locations, use pull boxes that are rated for wet locations. These boxes are designed to prevent water from entering and damaging the electrical connections. In corrosive environments, use pull boxes that are made of corrosion-resistant materials. Regular inspection and maintenance of pull boxes are essential to ensure their continued safety and reliability. Inspect pull boxes for any signs of damage, such as cracks, corrosion, or loose connections. Tighten any loose connections and replace any damaged components. Keep pull boxes clean and free of debris. Remove any dirt, dust, or other contaminants that could interfere with the proper functioning of the electrical system. When making any modifications or additions to an existing electrical system, always obtain the necessary permits and approvals from the local electrical inspector. This will ensure that the work is done in accordance with applicable codes and regulations. The size of the conductors being pulled through the conduit and pull box also affects the size requirements. Larger conductors require larger bending radii, which in turn require larger pull boxes. The NEC provides tables and guidelines for determining the appropriate pull box size based on conductor size and conduit configuration. In some cases, it may be necessary to use multiple pull boxes in a long conduit run to reduce the pulling force required. Strategically placing pull boxes can make the wire pulling process easier and prevent damage to the conductors. When selecting a pull box, consider the type of cover. Some pull boxes have screw-on covers, while others have hinged covers. Hinged covers provide easier access for wire pulling and maintenance. Choose a cover that is appropriate for the application. In areas where the pull box may be subject to physical damage, consider using a pull box with a reinforced cover. Reinforced covers provide added protection against impact and other types of damage. Also, be aware of the working space requirements around pull boxes. The NEC specifies minimum working space clearances around electrical equipment to provide safe access for maintenance and repairs. Ensure that there is adequate working space around the pull box before installing it. When working with aluminum conductors, use connectors and pull boxes that are specifically listed for use with aluminum. Aluminum conductors require special connectors to prevent corrosion and ensure a reliable connection. Consider the weight of the conductors when selecting a pull box. Heavy conductors may require a pull box with a stronger support structure. Ensure that the pull box is adequately supported to prevent it from sagging or pulling away from the wall or ceiling. When installing pull boxes in hazardous locations, such as areas where flammable gases or vapors may be present, use pull boxes that are specifically listed for use in hazardous locations. These pull boxes are designed to prevent explosions and fires. Furthermore, ensure that all conduit connections to the pull box are properly sealed. Use conduit fittings that are listed for use with the type of conduit being used. Seal the conduit connections with a suitable sealant to prevent moisture from entering the pull box. When installing pull boxes in concrete walls or ceilings, use concrete anchors that are specifically designed for electrical applications. Concrete anchors provide a secure and reliable attachment to the concrete. Also, be aware of the potential for electromagnetic interference, or EMI, when installing pull boxes. EMI can interfere with the operation of sensitive electronic equipment. Consider using shielded pull boxes or a conduit to reduce EMI. When working near energized electrical equipment, always maintain a safe working distance. The NEC specifies minimum approach distances for qualified electrical workers. Use appropriate personal protective equipment, such as rubber gloves and sleeves, to protect against electric shock. If you are not familiar with safe work practices, seek guidance from a qualified electrical worker or instructor. Remember that electrical work can be dangerous. Always take precautions to protect yourself and others from harm. Consult with a qualified electrician if you have any questions or concerns. Consider the use of cable trays as an alternative to conduit in some situations. Cable trays can provide a more flexible and cost-effective solution for routing electrical cables. However, cable trays must be properly supported and grounded in accordance with the NEC. When using cable trays, be sure to select the appropriate type of cable for the application. Some cables are not suitable for use in cable trays. Also, consider the fill capacity of the cable tray. The NEC specifies maximum fill levels for cable trays to prevent overheating and ensure proper ventilation. When installing pull boxes in areas where there is a risk of flooding, use pull boxes that are watertight. Watertight pull boxes are designed to prevent water from entering and damaging the electrical connections. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage surges. Surge protection devices can be installed at the service entrance or at individual equipment locations. When installing pull boxes in hospitals or other healthcare facilities, follow the specific requirements of the NEC for healthcare facilities. These requirements are designed to protect patients and staff from electrical hazards. Also, be aware of the Americans with Disabilities Act, or ADA, requirements for accessibility. Ensure that pull boxes are installed in locations that are accessible to people with disabilities. Consider the use of tamper-resistant pull boxes in areas where there is a risk of vandalism or theft. Tamper-resistant pull boxes are designed to prevent unauthorized access to the electrical connections. Remember to always follow the manufacturer's instructions when installing pull boxes and other electrical equipment. The manufacturer's instructions provide important information about the proper installation and use of the equipment. When in doubt, consult with a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. Take the time to learn about safe electrical practices and follow them carefully. Your safety and the safety of others depends on it. Now let's talk about some specific scenarios where the distinction between junction boxes and pull boxes becomes crucial. Imagine you're wiring a series of lighting fixtures in a commercial building. The electrical design requires you to run a single circuit to power all the lights. To distribute power to each fixture, you'll need to make connections at each light location. In this case, you would use junction boxes to safely connect the wires from the main circuit to the wires leading to each individual light fixture. The junction boxes provide a secure enclosure for these connections, protecting them from damage and preventing accidental contact. On the other hand, suppose you're running a long conduit run from one electrical panel to another across a large warehouse. The distance is significant, and there are several bends and offsets in the conduit path. To make it easier to pull the wires through this long and complex conduit run, you would install pull boxes at strategic locations along the way. These pull boxes provide access points where you can insert wire pulling equipment and reduce the pulling force required. They also allow you to break up the long run into shorter segments, making the wire pulling process more manageable. Another common scenario involves adding new circuits to an existing electrical system. Suppose you need to add a new receptacle to a room that already has existing wiring. To tap into the existing circuit, you would use a junction box to make the necessary connections. The junction box provides a safe and convenient way to extend the circuit without having to run new wires all the way back to the electrical panel. Keep in mind that the NEC has specific requirements for the number of conductors allowed in a junction box. The box fill calculation, as it's called, takes into account the size of the box, the size of the conductors, and the number of devices, such as switches and receptacles, that are installed in the box. Overfilling a junction box can lead to overheating and other safety hazards. In situations where you need to run multiple circuits through a single conduit, it's important to use a pull box that is large enough to accommodate all the conductors. The pull box must provide adequate space for the conductors to bend and spread out without putting undue stress on the insulation. When working with low voltage wiring, such as telephone or data cables, the distinction between junction boxes and pull boxes is still important. Although low voltage circuits don't carry the same risk of electric shock as high voltage circuits, it's still important to protect the connections from damage and ensure proper cable management. In some cases, you may need to install both junction boxes and pull boxes in the same electrical system. For example, you might use pull boxes to facilitate the wire pulling process and then use junction boxes to make the final connections at each device location. The key is to understand the purpose of each type of box and use it appropriately. Always follow the NEC requirements and best practices to ensure a safe and compliant electrical installation. Remember that electrical work can be complex and challenging. If you're not comfortable working with electricity, it's always best to consult with a qualified electrician. A licensed electrician has the knowledge, skills, and experience to handle any electrical task safely and effectively. By understanding the difference between junction boxes and pull boxes and following the NEC guidelines, you can ensure that your electrical systems are properly installed and maintained. This will help to protect your property, your family, and yourself from electrical hazards.